Good morning to all. Myself Dr. Hariprasad Uppara from Chemical Engineering Department. So in this semester I'm going to handle one elective course that is Pilot Plant and Scale-up Studies. Uh, so the prerequisites required for this course are heat transfer, mass transfer, momentum transfer, as well as you should have some idea on chemical reaction engineering and process equipment design. So this is a 3 credit course, and the course was divided with 5 units. So in the first unit we are going to study with the concept of prototype, model, scale ratios. So here we are going to discuss why pilot plant studies are very important. It is basically the pilot plant studies are needed, which can help to bridge the knowledge gap between the laboratory scale experiments as well as in the full scale plant experiments. So, and also the concept of prototype is nothing but it is a large scale apparatus before the commercialization, and whereas model is nothing but the geometrically related model where the laboratory scale experiments will be carried out to obtain the data of the future large scale experiments. So and also we are going to study what is the role of pilot plants in large scale apparatus, so as well as what are the factors that are going to affect when we try to study the laboratory scale experiments in the prototype studies. So all those things will be considered here in the introduction part. When we comes to the second unit, basically we are going to study the principles of similarity. So here it is divided with five principles of similarity. One is static similarity, dynamic, kinematic, thermal, and chemical similarities. Along with that, we are going to deal with some real applications and examples of all these similarities in the chemical engineering applications. And also, we are going to study one of the technique called dimensional analysis. As you already studied this technique in your fluid mechanics, but here the application point of view it is completely little different when we compared with what we have studied in the fluid mechanics. So basically the dimensional analysis is a technique which is used to obtain the equation of behavior of any system in terms of dimensionless variables. Like for example, if there is a flow in a system where we are defining what are the dependent variables and independent variables, and based on that, this dependent variable, if I consider in a flow of system, pressure drop is my dependent variable. So this pressure drop is going to affect on what parameters that we should identify. Based on those parameters, we are establishing the dimensionless groups. As I told you, the example fluid flow system pressure drop coefficient is the function of Reynolds number, Weber number, and Froude number. So based on this, we are equating the dimensionless groups in the model and the prototype, and based on that, we are estimating the or predicting the performance of the parameters in the prototype. So that is the advantage of using this dimensionless groups. And in the third unit, we are going to discuss the design concept. So in this design concept, we are majorly discussing the static regime. Under this static regime, load controlling regime, mass controlling regime, and dynamic regime. So again, under this dynamic regime, we are discussing about surface tension controlled regimes, viscosity controlled regimes, gravity controlled regimes. Means basically in this chapter we are developing the scale up rules and criteria conditions for the different regimes. So mostly if you take in any chemical engineering systems, two regimes are very important. So one is chemical regime and dynamic regime. For example, there is a flow of system, along with that some reaction is been considered. If reaction is also there in that particular system, then we need to identify which regime is prevailing, more predominant in that particular. Based on that, we will eliminate, and the predominant resistance we are considering into picture when we study the scale up conditions. So suppose if the reaction rate is very slow, in that case we are taking the controlling regime as the chemical regime. Or if we take the dynamic regime is slow, like mass, momentum, heat transfer, if it is slow in that particular system, then we are taking dynamic regime is prevailing in that condition. So in order to find out this regime which one is prevailing more, we are studying temperature change of regime as well as degree of mixing regime. So based on this concept, we are identifying which regime is predominant and how it is going to affect when we study the model and the pilot plant studies. And whereas unit 4 and unit 5 we are going to study with particular engineering applications of our chemical engineering. Majorly it is covered with uh, developing the model equations or scale up equations for the mixing system. Suppose as we in the laboratory we are doing some mixing, we are carrying out two reactants get mixed and getting into the product. So when we if we can create geometrically similar model which is having larger size, in that case how the impeller speed and how the impeller size it is going to affect, all those things we are going to predict based on the correlations in unit 4 and unit 5. So and also in unit 4 and unit 5 it covers with the mixing of the systems as well as packed bed absorption column, stripping column, extraction column. For all these chemical engineering equipments we are going to develop the model equations. Based on that we are trying to estimate or predicting the performance of the system in the prototype studies. So and these are the textbooks that we are going to follow in this course. Majorly one of the textbook called Pilot Plant Models and Scale Up Methods in Chemical Engineering. So the author is Johnston and Tring. So most of the syllabus was covered in this subject only. We have the soft copy of the subject as well as hard copy. So it is very easy to follow this subject. And reference books are also given, Marko Djokovic and one more book is Scaling Up the Institution of the Chemical Engineering. So here, so this is very important subject, as you might have already studied in the lower semesters of the basic subjects like heat, mass, momentum transfer. Now you are applying for the industrial applications, and where if you can change the conditions, if you increase the dimensions of any particular equipment, how the parameters are going to change, we are going to study in this subject. So I hope this subject it will be very interesting and helpful for your future job purposes also. So thank you one and all.